We're going to use the Cournot duopoly model to analyze the advantage of producing more quickly and sooner than your opponent. So determining whether it's profitable to rush to choose your output sooner. This is a problem that Microsoft faced with its early Windows programs. In a rush to beat out Apple with a graphical user interface, they compromised the quality of their product. Turned out in that case it was worthwhile, and Microsoft became a very valuable company with a lot of profits from Windows. Another way to compromise is to rush into production and increase your production costs, and that's specifically what we're going to look at. In detail, let's compare the Cournot model to the Stackelberg model. What we already looked at in a previous lesson is the advantage of being a Stackelberg leader versus a follower. You get more profit from being a leader than a follower. In between those two is the profit you would get by being a Cournot competitor, where you produce at the same time. What we see from the comparison of all three of these numbers is the worst is to be a Stackelberg follower, better than that is to be a Cournot competitor, and best of all is to be a Stackelberg leader. What we're going to look at is a problem with the Cournot model that could compare being a follower to a Cournot duopolist and the advantage of being the duopolist over the follower, or the leader over the Cournot duopolist. So here we have a practical problem. We have these two companies, they have a decision to make. The demand for both companies' oil, the total demand is here. And one of the companies can set up now and you set up later, and you both produce at a marginal cost of 1. A second option for you is that you hurry up and you set up at the same time as them. And your hurry means that your marginal cost increased to 1.1. So which option is better for you? Is it better to hurry up to avoid being last and instead move at the same time as your opponent? Is that worth it if it means that your cost of production have increased? So the first step to answer that question is to formulate the problem. In option A, you're the follower in a Stackelberg duopoly. Here's your inverse demand, and there's the cost. In option B, you're firm 2 in the Cournot duopoly, and here's the inverse demand, and here's the cost. Now, in a Cournot duopoly, it doesn't matter whether which firm is labeled 1 or 2. I chose to label you as firm 2 in the Cournot duopoly since you are definitely firm 2 in the Stackelberg duopoly, just to facilitate comparison. So in option A, the next step is to figure out your profits. Here's the inverse demand, and here are the marginal cost. You'll have to remember back from a couple lessons ago how to solve the Stackelberg duopoly. You start with firm 2's move, that's the firm that moved the follower. They compute marginal revenue, as always, by taking the inverse demand curve and doubling the slope on their quantity term. You equate that to marginal cost, solve that for firm 2's reaction, their best response to what firm 1 does. So move just the Q2 to the left-hand side and then solve that equation. Using that best response, firm 1 first computes its revenue. Revenue, as always, is price times quantity. Plug in that best response, do some algebra, get this expression here. Then take a derivative to find marginal revenue, equate that marginal revenue to firm 1's marginal cost, and then solve that to determine firm 1's output. Plug firm 1's output into the follower's best response function, which is here. Plug in the Q1 of 1 into here, and you get that firm 2 produces 0.5. Plug both of those quantities into the inverse demand to get a price of 1.5. Plug the quantities and the price into profit to compute the leader's profit of 0.5 and the follower's profit of 0.25. Now find the Nash equilibrium in option B, where you have the inverse demand curve. The other firm's marginal cost is 1 and your marginal cost is 1.1. So we're going to find the Nash equilibrium. We imagine that firm 1 and firm 2 got together. They both agreed on what they're going to produce. And then we look for the agreement that would be self-enforcing. So that would mean that firm 2 finds it worthwhile to live up to what they say they're going to do. Firm 2's profit maximizing output is found by equating their marginal revenue to their own marginal cost. And this is an equation that determines firm 2's best response to firm 1's output. In a similar way, firm 1 gives a best response to firm 2's choice by firm 1 equating their own marginal revenue to marginal cost. Their marginal revenue they find from the inverse demand by doubling the slope on their quantity term. That leaves this equation. So solve both this equation and this one for these quantities. Maybe you need to pause the video here and take a couple minutes to solve that. I would use elimination of variables, but you're free to solve that however you want. Given those quantities, plug that into inverse demand to find the price of 1.7. Plug the quantities and the price into profits to compute these values. For firm 1, it's 0.49, and for firm 2, it's 0.36. So from the previous slide, option A was computed as a profit of 0.25 for PetroChina, being a Stackelberg follower was 0.25. And then up here, profits as a Cournot-Duopolis were 0.36. So the 0.36 is better. It is better for PetroChina to choose option B.